So yeah, this project was for the government, so we don't have any pictures we can share, but it's such a cool project, we think. I'm hopeful that just sharing about it will be enough reason for why Ignition can help you say yes to any automation project. So from fragmented BDAs to a single pane of glass with Ignition. I know you're probably thinking, what's a BDA? BDA stands for bidirectional amplifier. Not many people know what a bidirectional amplifier is. Police departments, fire departments, other government and first responder agencies all use radio systems to communicate, as we're all aware. And as you can imagine, these radio systems are critical for public safety and emergency response. In the event of emergencies, the ability for first responders to communicate clearly is huge for ensuring the safety of the public and the people in the buildings. Bidirectional amplifier is a device that enhances radio signal coverage within buildings, allowing first responders to communicate during emergencies, even in areas with weak or even no signals. These are buildings like hospitals, high-rise buildings, sports arenas, government buildings, other facilities where reliable communication is crucial for public safety. And, you know, not only for obvious safety reasons, but also because in many times installation and status of these devices is typically regulated by building codes, which I never knew until this project. So we were approached to design and develop a monitoring and alarm notification system for Washington, D.C. and their 230 plus bidirectional amplifier network for the city. And we immediately knew Ignition was the right tool for the job. Yes, Ignition does SCADA, which we all know. Yes, if you can dream it, you can build it, as the famous Ignition slogan goes. But you can also develop a system to monitor critical radio infrastructure for the capital of the United States, which is pretty stinking cool. And so I know myself and everyone else who's used Ignition for a long time, it's hard to find something you can't do in Ignition. The bidirectional amplifier network for Washington, D.C. prior to this project had little to no monitoring capabilities. The operators of the devices detected problems either by visiting the site manually and doing inspections and finding they weren't working, or by users reporting poor radio signals. So the goal of this project was to change that. They needed a way to monitor all of these BDAs and be notified automatically which ones weren't working before people noticed it, all without having to physically visit the site. The challenge was integrating with various BDA vendor hardware. It's not all the same. Not being allowed to have any system downtime, right? This is government and first responder radio systems we're talking about, and dealing with tight government budgets. But all three of those were easily overcome with Ignition. So architecture at a glance, we did implement a VPN mesh network using Tosibox that we wanted to highlight. That allowed Ignition in the gateway to remotely connect with all of the BDAs over the VPN network. Ignition has the ability to communicate with these bidirectional amplifier devices natively using the SNMP module in Ignition. And then beyond that, it's just the beauty of Ignition we have all come to love. Tags, UDTs, scripts, alarm notification pipelines, and then visualizing all this live data on the native map component in Ignition perspective. And here's just a very basic and generic diagram of what I just spoke to in regards to the architecture, but you can visually see how an amplifier on a building is connecting over the internet using VPN technology, Ignition connecting to it and displaying that information on the prospective application. And from here, I'm going to turn it over to Kyle to take over the rest of the presentation on this one.
Awesome, thank you. So just wanted to do a quick dive on the technical side of stuff so we can kind of talk about how we made this possible, why Ignition let us say yes to this project. We were able to create a user-centric web portal that was built entirely within Ignition, leveraging the native map component to enable the real-time GPS tracking, status color coding, one-click shutdown restore functionality for each of the BDAs, one-click remote device portal access, and live KPI dashboards tailored to the end user's priorities. The rollout itself, we executed a 6-month phasing process where we part of our requirements where we had 0 downtime for the existing radio services, and we were able to do that phased onboarding with no interruptions and be able to have a high success ratio there. The first biggest thing, like I kind of mentioned earlier, that gave us the biggest yes was the native map component. The visualization of these BDAs was crucial to be able to see the current statuses at a glance of every BDA throughout the system, be able to get a quick health metric, and then also be able to inspect and go to any of those BDAs via that map component and be able to pull up a KPI about that, about any of those devices dynamically. We were able to leverage UDTs and scripting that allowed us to automate and the creation of the UDT instances themselves, as well as any metadata that would be driving that would be necessary for the map component, allowing each new device to be fully integrated into the system dynamically. This approach not only made the system evergreen, but it also slashed all of the engineering hours that were originally thought to be required. We accelerated the development via those means, and we also improved long-term maintainability and reduced requirements from the operator side and to have to get involved in the development of those tags and placement on the screen, stuff like that. That all got removed. The open driver architecture that Ignition allows us to drop in Chimera's SNMP module with no friction, no custom coding or workarounds required to fully integrate there. We have the built-in alarm escalation logic where we have the alarm pipelines that let us meet the 24/7 operational requirements without any third-party services or plugins. And kind of finally is that we were able to utilize Ignition's cloud-ready security architecture to help us satisfy the internal district policies and federal compliance under the FedRAMP right out of the box. So the big wins that we had within the first 6 months, the results came fast. We were able to go live, and the big gains that we had were that we had the alarm detection time drop from 2 hours to under a minute, allowed us to transform how quickly the teams could respond to these outages. Manual site visits. Oh, thank you, Pat. The manual site visits, which they had averaged before, was about 15 to 20 per month, fell to fewer than one, freeing up field resources, cutting off the truck rolls. RF interference incidents were reduced, which had originally happened several times per year. We had none over the course of the first 6 months, thanks to the proactive visibility and monitoring that was enabled by the map component and the scripting objects. These wins allowed for early confidence to be built, and the organization really dove in, deploying more of these BDAs throughout, getting them connected up, and just seeing it roll out itself almost. And that's pretty much my summary there. Speaks for itself almost.
Yeah, thank you guys for sharing that project. Pat and Kyle, that is definitely an amazing project. And it really showcases that you could build any kind of application, right? It doesn't have to be a traditional SCADA or HMI. And here, leveraging the SNMP module that was built using Ignition's SDK, it shows how you can easily extend the platform to do more. And I also want to key on the fact that you built the application to be dynamic, allowing you to easily connect more sites without having to go in the designer and do any manual configuration, right? It was kind of plug and play automatic discovery as you go forward, which is it's pretty incredible to see that kind of project being developed. So thanks again for sharing that.